Okay, part 2 of this video. Number of devices are included in a household electrical circuit that gives protection to consumers, the appliances and the circuits. Apart from the fuse, name 2 of these devices. So you've got a miniature circuit breaker, which is an MCB. These are the ones that you'll find in your consumer unit. These are the ones they use an electromagnet if the current gets too much. So if the current gets too high, it triggers that electromagnet. Now that doesn't protect the consumer. It protects the appliance, because if there's a fault developed and you get an electric shock, you've got to wait for that now to kind of generate the current for it to knock off. So these things are a little bit more sensitive. Residual current circuit breakers, RCCBs, they detect a change, or there's an imbalance between the current in the live wire and the neutral wire. So these protect the user, because as soon as they detect that, if you touch it and you start getting an electric shock, they will shut off straight away. So this protects the consumer. Again, electromagnet, but very, very sensitive, because they detect an imbalance between current, whereas these need just once you've got a high current, then that will trigger the electromagnet. These are usually low ratings, whereas these are higher ratings. You also find these in your consumer unit. They're just the bigger switches. Okay, so there'll be maybe 3 or 4 of these MCBs, and then an RCCB protecting that. A surge in electricity causes too much current to flow in an electric kettle. The fuse in the plug does not break, but the kettle circuit switches off. Explain which safety feature. So I've just kind of explained that now. So the MCB, if there's a surge, it's going to be MCB. That's not the residual. The residual detects the change in current. Sorry, I shouldn't say change. The imbalance in current between live wire and neutral wire. So I said MCB breaks the circuit if there's a current surge. It does act faster than a fuse, because that fuse takes time to melt that wire as well. So they are better than a fuse. There's also other positives. It can just be switched back on as well, can't they? You don't have to keep buying another fuse, because once the fuse melts, you've got to buy a new one. Whereas these MCBs, the electromagnet, pulls the pin and it breaks the circuit. So you can just push the pin back in, providing the fault is fixed. The live lead, or I should say wire really, touches the metal casing of a fridge. Explain carefully how a safety feature in the household electric circuit makes the fridge safe for the user to touch. Well, this comes down to earth wire now. If you've got a metal appliance, you need an earth wire, because if that live lead comes loose and touches the metal, then you are going to get electric shock. But what an earth wire does will send that current down to the earth, down to the ground, because all electricity likes to be earth. There is now a difference between the live and neutral current, so the MCB is going to, rather than you taking that current to the ground and then the MCB kicking in after you've probably had quite a shock, the earth wire is going to do that, and then that MCB, that current's going to surge and it's going to break the circuit. Of course, large current flows because it is a low resistance path, so they've made that earth wire very, very low resistance to easily take that current and to make it surge. Okay, it's going to melt. The path of the fuse is going to melt and break the circuit. This question then, I got confused with this because I'm so used to plugging. Sort of when you do the plugs, this is facing towards you. I know it's hard to do because it's a diagram, but the neutral is on this side. The live is on this side when you've got it the other way in the earth. So now, when it's swapped round, it's the opposite. So now X is going to be the neutral, because it's kind of turned round. The Z is going to be the live, and the Y is still the earth. So just takes a bit of thinking about that. And then the other end of the cable is connected to a 2.3 kilowatt chainsaw, which is operated on the 230 volt main supply. Use the equations, just giving you the equations here. Current times voltage, power, and resistance. So This is nothing to do with price. This is nothing to do with cost. This is nothing to do with how many units are used. So 2.3 really does need to be converted now back down to watts. So I'm going from big to small. So I'm going to need to multiply that. So let's have a look what I've done here. I've said, I've used my triangle. Well, I don't need a triangle because it's giving me there. Look. Power equals current times voltage. The current through the chainsaw. Oh, yes, I did need to rearrange actually. So I've done my triangle here. So I equals P over V. P over V is 2300 because I converted. Okay, I've made that into watts. Over 230 equals 10 amps. There it is, look. And then the chainsaw, the resistance of the chainsaw is going to be, and they've given it there. So I equals V over C. Well, it should be I, V over I. And you can do that from this triangle anyway. It's going to give me 23 ohms. 23 ohms. And then I think, how many questions? Oh my God, this is a massive paper. Nearly on 20 minutes here. I'm going to start rushing through this now. Give 2 reasons why the RCD gives greater protection than the earth wire and fuse. Now, RCD is the same as an RCCB. So they'll probably sort that out. This is from an old exam board. I've said it's more sensitive to current changes. Faster acting does not need to melt any wires. Remember, it detects an imbalance between live and neutral wire. This one was a bit tricky because you've got to have a look at the switches, which way they go. You can see the current can if they're both switched up, the current can flow along here. But if one is up and one is down, okay, if the top switch, if it's down, it's broken the circuit, so there's not going to be any light from that lamp. But if they're both down, you can see they can flow across the bottom now. So I've said they're on. And then use an equation, current equals power times voltage, calculate the current flowing through the lamp. So I equals P over V, 115 I've got from the 115 watts, look, it's power there, and my voltage did tell me in the question it was 230, didn't it? Didn't it tell me? Ah, there it is. It's there, look, 230 from there. It's all about spotting where this information is, and I even like to write it out sometimes. I got V equals 230, P equals 115. Anyway, I've got to rush on because I'm going to run out of time for the video. 0.5. State why a 13 amp fuse would be unsuitable for this circuit. It's way too high. Way too high. You're looking at about a 3 amp fuse for this. You want to use a 13 amp. So a 3 amp fuse is closer to the value I've said there. Which wire is included in the main circuit but is not shown on the diagram? So there's no earth wire there. No earth wire. Last question then. It says another numeracy sort of question, yeah? Let me shrink these up. How am I doing for time? 19 minutes. Okay. The table gives information about ways of reducing energy costs in a house. So I've got cost here, savings per year, savings in 10 years. So if you're good at multiplications and recognizing that 150 times 10 is 1,500, and then 25 is going to be times 10, 250, and then obviously going backwards here from 1,000 to 100. Yeah, because there's a multiplier of 10. Calculate the payback time for the solar panels. Now, payback time is just the time it takes to pay off either the extra cost of buying something that's energy efficient. And well, it's not either. That is it. That's what it is. It's the time taken to pay back that extra cost. So, well, I've missed that. This is the number of years taken for the savings made to pay the cost of insulation, so the cost of it. So I've got lamp costs £100. Savings, it saves. So complete the payback time. I've missed the question here. Complete the table. For the solar panels. Sorry, yeah. So fit in solar panels. Saves £25 a year, replacing lamps with saving lamps. What have I done here? After 4 years, already saved 100. I have no idea what I've done here. Calculate the payback time for the solar panels. See the cost of the house. Lamps equals cost £100. Saves £25 per year. So, replacing lamps with energy saving lamps. I've done the wrong one, haven't I? I have done the wrong one. Let me check my mark scheme. 150. Yeah, what it should be is 150. Yeah, why have I done that? Okay, I'm going to come back to this question. Oh, I tell you exactly what I've done here. I did the first one wrong, which is in pink, and then I did it in blue, look. I did it in blue down here. So 2,400 is what it costs to set up. It saves 115 each year. So how many years will it take? It'll take 16 years. So 150 into 2,400. Why on earth did I do this pink one? Have no idea why I did that. Crazy, crazy, crazy. But there we are. I've done 2 there. But there's no need for this. So I'm probably going to... Anyway, you're going to all have a good laugh over that. Even if any of you got to the end. That'd be interesting. And you can say, oh, Mr. Timothy, what are you on about, man? Crazy, man. Anyway, so that is the last page. Have fun.